Well, in this last video of the course, I'm including something which crops up from time to time and includes really a little kind of trick. But because it comes up in questions, I thought it'd be good to, for completeness, just to make sure it's included. And it's this fact, that if two equal masses or particles of equal masses collide elastically, but in two dimensions, so not head-on, they will move off at a right angle, at 90 degrees. So just take a moment to absorb what that means. And the thing is that there are questions where you kind of basically have to prove this, which is pretty tricky unless you've seen the trick of how to do it. So I'll go through that and then I'll put a question then for you to have a go with the video solution. So, well, what that's basically saying then is that if you have this situation that we've already met for two dimensions, so you have a body of mass m1, well, let's just say this body has momentum p1, and this body, which is of equal mass, doesn't have any momentum, so initially, but it hits at an angle, so they go off at a different angle. That's what this is saying here, isn't it? So this might be momentum p2, and this might go off down here with momentum p3. Now if we do this, we might see that it looks like a right angle there, that they're sort of moving off from each other. But how do we actually, prove that? Of course, let's put this in. This is before the collision. This is after the collision. Well, first of all, let's do a momentum conservation vector diagram. And so if we do the momentum before P1, then we can draw an arrow like this. I've done it just longer this time to make a nice big clear diagram. And then P2 and P3, the momentum after has to be equal when we vector sum them, the momentum after. So P2 plus P3. And we know it's going to be something looking pretty close to a right angle because that's what we're trying to prove. So there we are. So that's P2, that's P3, the grey one is P1. Let's write all those on. So there's P1 going that way, that's P2. And the idea is that P1 is equal to P2 plus P3, but we have to prove that that would be a right angle, yes, because they're moving off at a right angle. So, the other key thing here is that the collision has to be elastic for this to be true. So that's a kind of clue. And if the collision is elastic, we know that kinetic energy is conserved. So we know that EK before, that EK initial equals EK final. And this is the way to roll in this one, because EK, remember, we've got that new equation now, that EK is P squared over 2m. So the initial EK is P1 squared over 2m. But the final kinetic energy is the kinetic energy of the two particles added together. So it would be P2 squared over 2m, so that would be the kinetic energy of this guy, plus P3 squared over 2m, which is the kinetic energy of this guy. So if the collision is elastic, that must be true. But because the masses are equal, you can see that the masses there are going to count, 2m is the same in each case. And then what you get is P1 squared equals P2 squared plus P3 squared. But of course, if that's true, then it's a right angle triangle, because that is, as it pertains to this triangle here, that is Pythagoras' theorem. And so there you are. So like I said, if you've never seen that before, I don't know how you're meant to do that in the exam. So I've included it here. Does crop up from time to time.